All right. Hi, everyone. Thank you for joining us. Before we begin, let's take a moment to reflect on the land that we're on and its history. We acknowledge that the land that we are meeting on today is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, and the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. We are most grateful and respectful for the use of this land. And we have with us today for the industry colloquia Dr. Hamid Hussein Varikkodan, who is a climate risk and disaster risk reduction specialist with over a decade of experience advancing climate resilience across India. He has led groundbreaking risk assessments and adaptation planning for governments, research institutes, and global partners. And his work helps bridge science, policy, and practice to build safer, more climate resilient futures. Please join me in welcoming Dr. Hamid Varikkodan.
Thank you so much. Thank you so much for your wonderful introduction. So, yeah, shall I start?
Yep, go ahead.
Okay, yeah, one sec. Okay, so yeah, I'm Dr. Hamid. So I work as a senior technical consultant for climate risk at Jacobs. What we exactly do is like we do climate risk assessments for large infrastructure projects, like if I want to put it very simply, if you're constructing an airport, like we'll 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 try to understand how does the climate profile looks like for that airport in future. For example, if the temperature varies in future, what is the risk associated with the increase in temperature? And we basically quantify the temperature risk, and we actually propose the adaptation strategies or the mitigation strategies to the design in all phases of the construction of that particular airport. So this is the sort of work we do. I also have worked with various governments, working on drafting various state action plans for climate change and all these things. So in today's talk, I really wanna talk about how I'll first give an introduction to climate change, like what does actually climate change means to our planet Earth, what are the impacts, and what are the drivers of climate risk and all these things. And after that, I'll talk about the climate vulnerability profile of India, like how does a country like a multi-diverse, multi-climatic zone country like India adapt to climate change, and what are the vulnerabilities, what are the impacts, and how we can address those risks. Okay, so before any, so I mean, let's just get into the topic. Okay, so I mean, uh, before I start, like, is this should be an interactive session, or like first I will give the presentation and then you guys will be asking me questions, or how does you guys want this to be?
It depends on how,
Okay,
whichever
okay.
format you want. Yeah.
Yeah, no problem. So you guys are actually free to,
Yeah.
ask question any time of my presentation. So yeah, so let's understand exactly what is climate change, right? So before that, like before understanding climate change, you all will be familiar about these two terms. One is climate, other one is weather. So people may have confusion. So I'll just quickly go through that. Weather is the day-to-day atmospheric conditions, like hot is today, what is the temperature today. Climate is something, the average of all the weather over a 30 years or a 20 years of lifespan, like that's what climate is. Okay, so it's like average temperature conditions over a long period of time. Okay, most probably 30 years of time. But when you talk about weather, it's the day-to-day atmospheric condition, like how hot it is it raining today, all these kind of stuff. So now we understand that climate change basically refers to the long term alterations in temperature, precipitation, weather patterns and all. So you might have noticed, like there is something unusual, right? Like earlier we used to get this much of rainfall in this particular period of time, but these years we are not actually getting it. Or like you could you could also see that like there is an increase in rainfall, a sudden rainfall or something, forest fires being increased and all these things. It's all due to basically the phenomenon called as climate change. Okay, so what exactly it is? So basically, the quantification is like this: the global mean surface temperature has already risen about 1.2 degrees Celsius since pre-industrial times, leading to more frequent and extreme intense weather events, basically. So you might have seen flash floods occurring and all these things. So the culprit here actually is the change in climate. Why does this happen? It happens due to the emission. You all know about it, right? It's basically due to the greenhouse gases, right? We call it as GHGs, like basically CO2, methane, nitrous oxide, water vapor, all that gets trapped in the atmosphere, and it acts as a, the you might have known this greenhouse effect, right? So it gets trapped in the atmosphere and the global temperature actually increases. So, which basically increases the global surface temperature, and which, which will accelerate your extreme weather events, flash floods, all these things. So you might have seen in newspapers like Antarctica's ice are melting, there are frequent flash floods in US, everywhere in Asia, and there are like, forest fires which occurs in Australia and all, like frequent forest fires. These all can be connected to uh, your climate change. Okay, so see, then why we actually need to talk about climate change? Is it a real problem? Yes, it is a real problem, right? So now we are seeing escalating disasters like flood that I have already spoke about it. Then it's climate change is not a physical risk alone. It's a major humanitarian crisis that also, it's a major humanitarian crisis, basically. So, over 200 million people may need humanitarian assistance each year due to climate-linked hazards by 2050. For example, we have these small island developing nations, like, and also island countries like Maldives, and also low-lying countries like Bangladesh and all. So in 2050, we can even see climate refugees, because when the sea level increases, people won't be able to survive. Their economic livelihood, social livelihood, everything will be at stake. So it's a major climate change should be considered, or climate change is a major humanitarian crisis that the world is facing right now. And other thing is the economic cost. Like, climate change could reduce the global GDP by 18 percentage by 2050. So if we are not taking enough mitigation or adaptation steps, it will definitely affect the developing nations. Because, like, if you don't prioritize on adapting or mitigating to these climate risks, uh, then again there is a problem. Then, moral and generational imperative. Today's choices determine safety, equity, and habitability of the planet for future generations. So when we talk about the future generation, it's like, we have to safeguard this planet for our future generation. So we need to act now. That's why, we have to talk about climate change. Now, okay, sorry, okay, I'll come to this slide later. Now, if you talk about climate change, we need to understand the drivers of climate change, or the drivers, how does actually climate change impact people. So we call it as the vulnerability, like how much we are exposed towards climate change, right? Or climate risk. Okay, the risk caused by climate change. So we need to talk about these three things to understand what exactly is a climate vulnerability. Okay. So the drivers of climate vulnerability are these three things. One is the exposure, second one is the sensitivity, and third one is the adaptive capacity. Okay. So exposure refers to the extent to which people, assets, and ecosystem are in harm, such as floodplains, drought-prone zones, or heat-stressed cities. Now I'll come to I'll give you an example. Okay. You all know that cyclone is a climate hazard, which is, formed by formed by a low pressure that has been created in oceans or something. So climate change actually induces cyclones, basically. Okay. So if you consider cyclone as an hazard, okay. So if you have a place, if your locality is located in a coastal site, you are already exposed to a cyclone compared to a place which is far away from a coastal region, right? So if you are living in a coastal region, you are intrinsically exposed to that cyclone, and that is called as the exposure. Okay. Now coming to the sensitivity. Sensitivity again depends upon the socio-economical characteristics of that particular region. For example, if in that particular place or region, if all your buildings are not very strong, like, and if your population, if you have a very high population density, your sensitivity is actually very high, towards that. And if if people are really poor in that area, your capacity to actually go back to the normal is also less. So these are the factors that actually determine the sensitivity. Now coming to the adaptive capacity, like how adaptive you are, like the ability of the system to adjust to a particular hazard, right? Like if you have like good infrastructure, if you have good early warning systems in place, like you are probably going to get adapted to that particular situation well, right? So that again depends upon the country's economy, the policies what you have. All these things matters in adaptive capacity. Everything, like every socio-human drivers actually matter into the adaptive capacity. So all these three things actually defines the vulnerability. So if your exposure is high, you are highly vulnerable. If your sensitivity is high, you are highly vulnerable. But if your adaptive capacity is high, you are less likely vulnerable. That's how, you know, these things behave. Okay. Any doubts or any questions, or shall I move further? What do you think? Okay. I hope everybody got it. Okay. Great. Now, now again, I think I'll come to this point, like how we are going to, assess the climate risk, right? So you have to integrate again these factors: hazard, exposure, vulnerability, and you also have models. People often ask me, like, how do you quantify the climate in future, right? Like, how do you know, like, in 2050 what is going to happen? So we have something called as, uh, you know, global climate models, right? Like that basically, there is something called as IPCC, Intergovernmental Panel for Climate Change, which is basically under the United Nations. There are people, scientists, countries, organizations working on IPCC. They actually make climate projection models, and we get data from them. Like, again, it depends upon your emission scenarios. Like if you emit more, if your country is fully dependent upon fossil fuels, your emission is more. If your countries are going towards a renewable source of energy, your emissions are less. So there are like 6 or 7 adaptation, like emission pathways, that where we quantify the future climate. We'll get data about the future climate, temperature, rainfall, sea level rise, everything, right? So that's how we get data from the uh, global climate models. Okay, we call it as like RCMs, or we call it as GCMs. Everything like RCMs are regional climate models. Okay, now risk mapping, like you have to map the risk. If you have a locality and you need to know about like uh, how does your place looks like in 2050, what will be the temperature variations, or what will be the wind variations over there in 2050. You need to map all these risks. Okay, so that is also an integral framework. Then you need to talk to different people, because ultimately we are the people who suffer the impacts of the climate change. So you need to talk to people, you need to engage with the community to better understand how they want to actually adapt to the climate change. How do you make programs, how do you bend your policies that you can adapt to these climate change in future. Okay, so that's it. Now I'll come to India. Okay, like how does the scenario looks like in India? Like what are the climate threats and all? So in the right hand side, I have shown you the map of India with the various climatic regions. Okay, so uh, India is a huge country, like so we have like all these, like the eastern and west we have the Arabian Sea and the Bay of Bengal. We are very much vulnerable towards cyclones, especially in the eastern part, like in the Bay of Bengal. Okay, like we have like a lot of cyclones like yearly which happens in Bay of Bengal, but now due to climate change, usually in the western side or in the Arabian Sea, we don't see much cyclones, but after 2010 or like 2000s, we see an intensification of cyclones in Arabian Sea also. That is also probably due to the warming of Arabian Sea. Again, like in the north, you have this Himalayan region, like the entire mountainous region, where they are mostly prone to earthquakes, but we don't talk about it because earthquakes are not climate risk basically. Now, in the north, we also have, one sec. We have these, you can see the floodplains. Basically, there are like two major rivers, Himalayan rivers, which actually flows Ganga and the Ganges and Yamuna. So basically, those rivers are like perennial rivers. They get flooded every year. So all these northern plains get flooded every year. We also have a desert uh, in the northeastern side. How do I show? Sorry, one sec. Okay, I think probably I can show like, oh, sorry, really sorry. Okay, laser point. Okay, okay. So here we do have the desert, we have the Himalayan range here, we have the eastern and western and eastern coast. Okay. Now, you can see in India, historical warming has been below global average, but future projections actually say that like from 1.1 to 1.4 degrees, there will be a rise in temperature by 2100s. Okay, then India actually faces intensification of extremes. For example, usually we have to get, for example, you get a rainfall of 200 millimeter in like 1 week or something. But nowadays, like I'm living in a state called as Kerala, we actually got 200 millimeters of rainfall within 24 hours, and that actually triggered a huge massive landslide in 2024. And around 700 people were actually killed in those landslides. And in 2018 and 2019 we had intense flooding which actually flooded the entire state. So it's like the climate extremes, like the extremes are actually increasing. That's the trend now you are seeing actually in India, especially in the northern plains also you witness, like especially the places. I don't know how many of you were in India, but the hillside, hillside states like Himachal, Uttarakhand, all were flooded like in last monsoon. Okay, so this is basically becoming a huge problem in India. Now, this is the basic, condition. So India now, India is the India is the largest populated country in the world. So we have around 1.36 billion people. So that basically basically highlights the, social vulnerability because we have more people. So when disasters hit, there will be more people. More people are exposed to climate risk or hazard. Okay. Now the economical structure is like, around 40 percentage of the workforce are into agriculture. So the economic and social condition of the people, when I talked about the sensitivity again is higher in India. And we also rank 127th of 182 countries in the vulnerability ranking. Now, yeah, this is what I wanted to explain. We have Great Himalayan Mountains, Indo-Gangetic Plains, Peninsula Deccan Plateau, desert, coast, and islands. Okay, so these multi-climatic, conditions, multi-climatic geography basically makes us pretty much vulnerable to all sort of climate hazards. Yeah, again, these are some of the health risk caused due to climate change. Like you can have like there is a projected increase in heat related illness, diarrheal diseases, there is a agriculture decline, urban stress, basically there is a phenomenon called as urban heat island. So when you construct, kind of lot of buildings, there will be problems with the concrete. Okay, so we call it as urban heat islands, and there is a problem with thermal comfort. People basically feels thermal discomfort due to higher, you know, higher temperatures. Okay. Now, you know all these things like uh, mostly the summer temperature exceeds more than 30 degrees Celsius, and which basically makes people very uncomfortable, especially in the coastal region. Here the humidity at that time will be around like 80 to 90 percentage, and the temperature will be like more than 35 degrees Celsius, the peak summer temperature. So what will happen? There is something called as a wet bulb temperature. That basically makes you very uncomfortable. Even though the temperature will be like 30 to 35, but it will really make you uh, very uncomfortable. So that's again another problem. And the intense rainfall, what we receive in, during southwest monsoons and southeast monsoon. So again, if you see here, Kerala or the southern state is the first uh, place to receive the southwest monsoon. So we have like intense monsoons, during June, July, August. So again, climate change is making it worst because, as I told you, like we usually get like a good amount of rainfall in a long period of time. Now, what we are facing is like we are getting high intense amount of rainfall in a very short period of time. So that is actually making the situations worse. We have like seen like three major flood events now, one in 2018, 2019, and 2024. So that's the kind of uh, that's the kind of impacts that we are facing right now. Now this is like India, the projected temperature. As I told you, we got it from the climate models. So India could warm by 1.2 degrees Celsius. You think that 1 degrees Celsius is very small, but the impacts is actually very high. Okay, even a zero point 0.5 increase in global temperature can make a lot of difference. For example, it can melt, it has a significant effect on, the the Greenland ice or the Antarctic ice. Okay. So extreme temperature, again, the extreme temperatures are also getting very high. And we are now seeing like the places like Delhi, the capital city of India, which actually recorded like temperatures like 45 degrees Celsius and all, which was too much basically. Okay. Now again, there is a phenomenon which is coming. You probably have heard about it. It's called as La Nina. This year is a La Nina year, which basically again bring more cold waves. That means in cities like Delhi, North Indian cities like Delhi and all, though we are going to face extreme cold this year. Okay, like extreme cold in the sense like it can even drop to, because we are not very used to extreme cold, right? Now this year we are projected to have extreme colds and like long winters. Okay, so again, it's an atmospheric phenomenon. It's called as La Nina. That's again coming and hitting this year. So we need to be more careful this year. Now, yeah, this is like, you know, changing rainfall patterns, extreme precipitation, regional uncertainties, all these things are, again projected precipitation changes or extremes which can happen. Okay. Now again, other thing I have already talked about it, heat waves. Okay. Longer duration of heat waves, urban heat stress, all these things. Okay. Again, in increasing drought frequencies. Again, like, India is majorly an agrarian economy, so it's actually bad. Okay. Now, so again, flooding is another problem. Like by 2030s and 40s, around 13 to 34 million people could be affected annually by flooding. The most affected states are like Bihar, Uttar Pradesh, West Bengal. It's the economic losses, and we need to adapt to it. Okay, I'll come to that, how we are going to adapt to it. Okay. Again, coastal risk. I lived in an island for almost 10 years. It's called as the Andaman and Nicobar Islands. So I know, like, I have been in a, we have actually hit by a cyclone when I was there. So we have like, now the intensity of the tropical cyclones are actually increasing. Earlier, I told you the Bay of Bengal part or the eastern part of India were cyclone prone. Now the western part of India, especially the Arabian Sea, is also becoming, you know, a hotspot for cyclones. Okay. So yeah, these are some of the impacts. Okay, I'm not just going to all the details of it, but yeah, these are some impacts to the agriculture. Okay, climate change to food security. There will be a decrease in yield. Uh, these are some of the impacts to the urban climate. Okay, and these are some of the health impacts, and this is also a major problem. Okay, so excess deaths due to heat could rise by 160 degrees by 2030. Okay, and 276 by 2050 in South Asia, with India as a major hotspot. So this is the data which I have taken from the World Bank report. So a major problem is this one, like heat stroke. Suddenly heat strokes happen. People die of heat strokes. Okay, now we have to address it. Okay, I'm coming to that. Now, vector-borne diseases like malaria, all these things are increasing. Waterborne diseases are increasing. There is a stress and strain in the health system infrastructure. Okay. Now, how are we going to adapt to all these things? So, climate change doesn't affect one sector. It affects all the sectors. It affects the agriculture sector. It affects the industrial sector. It affects the tourism sector. It affects human health. It affects almost everything, right? It affects your transport, everything it affects. Now, how are we going to address these things? Okay. So as I said, now you are familiar with the variables of climate change or the vulnerabilities of climate change. One is exposure, the other one is sensitivity, and the other one is adaptive capacity. So exposure, pretty much you cannot do anything. If you are living in a coastal area, you are already exposed to the climate change, right? Like exposed to a cyclone. You can't stop a cyclone from being coming. Only thing what you can do is either you have to increase or decrease your sensitivity towards the particular cyclone or hazard which is coming, or you have to increase your adaptive capacity towards that particular hazard. How you do that? You have to do it by investing in resilient infrastructure. You have to make sure that your infrastructure is resilient towards towards a particular climatic hazard. So how do you know whether you're like how do you decide that thing? Like, as I said, like y- suppose like you just build a house. Okay, if you're going to construct your home, what are the things you should uh, basically consider while considering it from a climate change lens? What are the things should you consider? Can somebody answer my question? Like, you know if you're going to build a home, what are the factors that you should actually consider? Anyone? Okay.
You should like use materials and designs that can
uh
withstand the local climate or
okay, great,
cyclone.
great answer. Okay, so the first thing is like, okay, your point, I got it. You should use materials, everything. Okay. First, you should understand what are the hazards that I am prone to, that I am exposed to. You may live in a coastal area and like you won't be prone to an earthquake because you will not be situated in an earthquake prone region, right? So investing in earthquake resistant materials, that's basically a foolish thing, right? You are just spending, you are just wasting your money, right? So first you need to understand what is my vulnerability, right? First you should understand what are the climate risk that is actually present in my region. So you need to map those risks out, right? And you need to rank those risks. Okay, so here, suppose you are living in a coastal region. Okay, so you know that, okay, the chances of a cyclone coming and hitting is high. Okay, and you have to go back to the literature, you have to go back to the data. Okay, in future, how many is there any chance of a cyclone which is coming? You have to go back to the data. Then you have to design your home or building accordingly. Okay, so maybe like a cyclone can come, but there won't be any chances of a coastal flooding over there because sometimes your geography is bit elevated. So you don't have to do anything on coastal flooding, but you have to consider the cyclonic hazard. Then you have to build your structure according to, like, you have to make your structure a cyclone proof one. Okay. You don't have to make it an earthquake proof one, but you definitely going to make it a cyclone proof thing. So this is the first step, understanding the risk. Okay. Understanding the hazards. So first one is the hazard mapping. Okay. Then from that hazard, you have to map like how what is my proximity towards these hazards, how sensitive I am towards this, how sensitive my building towards this. Okay, now again, another thing, as a community you can invest in nature based solutions also. Like, if you are living in a coastal region, you can build more mangroves over there so that it can your nature itself act as a barrier to these high waves, storm surges, and all. Okay, that's one thing you can do. Then again, the other one is investing in early warning and preparedness. Okay. So this is a very crucial part. Okay, like how do you know? Like, I can give you an example. In 1999, there is an Indian state called as Orissa, which is located in the eastern side of India. In 1999, we had a super cyclone, which is called as a super cyclone. The speed of that cyclone was around more than 150 kilometer per hour. It was super strong. In 1999, we had like huge like number of people who died in that particular cyclones. Around like thousands of people actually lost their life. But fast forwarding to 2019, 2014, we had a cyclone in 2014. I forgot the name of that particular cyclone, but the speed of that cyclone was around like more than 250 kilometer per hour. Like it was, the speed was like enormous speed. But we had very less casualty, very less casualty. Do you know what's the reason behind it? Because by that time, India had a very good early warning system where we could predict that cyclone from the beginning. So that process was called as, like, the cyclone generating process is called as cyclogenesis. So from that low, it actually originates as a low pressure, right? So we had like very good surveillance system, very good radar systems that actually tracked the track of that particular cyclone. So we knew when that cyclone could hit the land. So we could evacuate most of the people at that la- at the time of landfall. Okay, so again, early warning systems plays a role. Okay, now again, the other one is financing. Like, how do you get people to basically as partners, or people's participation in doing climate resilience? Again, as I told, people should be really aware of the climate change, or at least the risk. Now, if you think about your locality, your place, your institute, you should be knowing, like, you should definitely know what are the climate risk that I am vulnerable towards. Like, you should have a sense of it. That's basically called as a risk informed decision making or something. Okay, like, you should be aware about your risk. Okay, that's the main thing. Every individual should be aware about their risk. Okay, so if a cyclone comes, was the most critical area in your locality or in your institute, at least, right? When a cyclone, I don't know if your institute is prone to a cyclone. I really don't know. But you think about it. If a flooding comes, what are the structures, or what is the main area that get flooded? You should have a sense of it. Okay, that's how these things should be communicated to the people, or to the students, or to the public community as a whole. What actually happens is, like, we really don't know about, like, our own risk. So if a flooding is happen, you should know, okay, these places will get inundated first, and people usually doesn't have an idea. But people like me, and the main objective is that to cultivate the kind of habit of this risk informed decision making. Everybody should be aware of our own climate risk. Not only climate risk, like every other risk, every other disaster risk. Okay, like, when you come to your college, what is your risk? Okay, like, you will have an idea, right? Likewise, you should also have an idea of, like, what is my risk? What is my climate risk to my institute, or the locality where your home is located? You should at least have an idea. Then our decision making is easy. It's actually very easy, right? Yes. Yeah, it's all these things. I think I have covered all these things. Like, like, you should have stakeholder inclusion. You should actually include people in the decision making process. And you should actually mainstream climate risk into all your developmental policies. Whatever policy your government is making, whatever policies your institute is making, there should be a climate risk element that is dissolved in it, so you have to think, okay, what if in future climate get worse? So it affects all the sphere of your life, like in all spheres of your life. It's going to affect. It's going to affect you economically. If you think it like, I'm not uh, giving you fear mongering or something, but it's just like, you need to understand it. So we don't know, because the extreme events are actually increasing. So it's better that people's participation should be there. People should be really aware about, our own risk. Okay. So like we can have evidence based decisions based on true data on ground. So that's what we people are doing. We take out the data, we tell people, according to this data, your temperature is going to increase. For example, I'll tell you one thing. Okay. So when I was analyzing the data in Saudi Arabia, Riyadh, for their airport, I could see there is an increase. So the normal summer temperatures is around 36 degrees Celsius. The peak summer temperatures can vary, like up to more than 40 and all. So I'll tell what we got by 2050. The summer temperatures is going to rise by, like, from 45 degree to 46 degree, the peak summer temperature. So there is a 1.5 degree increase. Now, what what is this increase in the temperature mean to your infrastructure? So when we analyzed the runway mortar or the runway pavement, right, that you are using in your runway, that can only sustain up to uh, a temperature of 45 degrees Celsius. Anything more than 45 degrees Celsius will actually melt your runways, or melt your pavement in the runways. So that's a huge risk for the aircraft when it lands, right? So we told them, okay, this is a kind of risk that you need to address. Now they have to come up with a solution, a very practical solution, right? It should be very practical. It's not like, okay, in 2050 we are just closing the operations, or we are shutting down the airport. No, you have to come up with a solution. So they told us that there is a particular polymer that can be mixed with your runway pavement, so that it will be stable up to 50 degrees Celsius. So that's the adaptation option over there. Okay, so you increased your adaptive capacity. So it can be either physical, it can be either sociological, it can be either at a community level. So I just gave you an example of a very particular scientific design treatment, so it can be anything. Okay. So yeah, so these are some examples. Like, there is a coastal protection, a mangrove restoration program that happens. These there are like proper heat action plans that are being developed. Okay, the first was in Ahmedabad. So now every city in India is developing heat action plans, basically. So that plan will tell you what to do. Basically, that will tell you from A to Z of, like, of people exposing towards high heat. Then climate smart agricultures and all these things, urban flood resilience in Chennai, like integrated stormwater management, like all these things. Okay. Now, just wanted to tell you some key takeaways. So climate change is a present reality. So the effects are like heat waves, drought, floods everywhere. Okay. Adaptation is development. So you basically have two options, like either to, you know, you cannot live along with, like, you have to, either you have to suffer, like we don't have to suffer. So the only option is to adapt to it. Okay. Because you cannot stop basically the climate change or the hazards. You cannot stop it. The only thing is that you have to adapt to it, right? We have to adapt to it. So it can be either from a physical point of view, economical point of view, a policy perspective, anything, right? Then, yeah, collaboration, the urgent collaboration between academia, government, You talk about the data, you take the data to people, you take the data to institutes, you take the data to academia, you talk about it, you tell the people, you communicate the risk to people so that people are aware about their own risk. And now we can create a safer future. Okay. Thank you so much. I mean, yeah, I mean, it was really great to have this session. Yeah, please carry on. Sagar. Yeah,
Yeah.
yeah, yeah,
Yeah, thank you for your presentation. It was really
yeah.
informative, and
Thanks,
I'm
thanks a
actually
lot.
working on a on a climate risk project at the moment, and
Great.
I ran into one question that
Sure.
I'm not sure, maybe you would be able to guide me in
Yeah,
answering.
yeah, great, great. Please shoot.
Yeah.
Yeah.
So the question is, how do you establish the causal relationship between carbon emissions and climate change? And how do you
Okay.
distinguish it from correlation? So how do you control
Uh,
for the confounding variables such as another factor being the cause, such as regular weather, long-term weather cycles, like changes of weather patterns, while CO2 rising can be just caused from something like a rising population?
Great question. Great question. So the first, I'll answer the first part of your question. How do you actually, correlate it? So, we are emitting, right? We are emitting. Every country has its own policies, right? Like some countries are fully depend upon the fossil fuels. Some
Yeah.
countries, like especially the like European countries, are more into renewables now. Country like India, kind of mixed. Like we are using renewables as well as we are dependent upon coal and all for all these things like fossil fuels. So there is something called as adaptation pathways or emission pathways,
Mm-hmm.
which is basically called as the shared socio-economic pathways, the SSPs. Okay.
Mm-hmm.
So that shared socio-economic pathways will tell you how your emission. Like if it's a okay, if the scenario is like this, okay, like your country is fully dependent upon fossil fuels. Okay. There is
Mm-hmm.
no regulatory board to control anything. There is no policy. Everything
Mm-hmm.
is business as usual. That scenario is called as SSP 8.5. Okay.
Mm-hmm.
Socio shared socioeconomic pathway 8.5. So
Mm-hmm.
if you see that projections, okay, I'll tell you another scenario where everything is on renewables. Okay. You have
Mm-hmm.
strict policies. Like you have strict policies, your country's emission is basically like zero. Okay. That is called as an SSP 1.2. Okay, 1.26.
Okay.
Now, if you compare these two things, the temperature in SSP 1.26 will be slightly lesser than this temperature, like the future temperature, maybe in 2050. If you analyze both these scenarios, the temperature in in SSP 1.2 will be slightly lesser than the projected temperature in SSP like 8.5. Okay. So because you are emitting high, so this is how you relate. Okay. Like with the scenarios. So it's basically the emissions of the carbon which is present in the atmosphere determines your pathways, and you have to choose a correct pathway that is applicable to your country. Okay.
Cool.
So if it's in
Is it?
Middle East state, we
Yeah.
usually use SSP 3.7. Please do
Mhm.
reach out to me like if you have
Yeah.
any questions because
Yeah.
it's a very dry subject.
Yeah. I'm just
That's why
wondering if
I
it's
really don't want to include that one in the
okay.
presentation. Yeah.
Okay. Okay.
Yeah. That's how the model works. That's how the
Okay.
global,
Yeah.
global climate models works actually. So, you have these 7 scenarios.
Yeah.
You have to
Yeah.
select the correct scenario,
Yeah.
depending upon your
Because isn't
location.
it, I
Yeah.
understood that it was a global phenomenon, so you can't really isolate country by country and say that a high.
Again, it again depends upon your policies. You have to read the national adaptation framework of that particular country where they are actually leaning towards. So there is something called as nationally determined contributions, NDCs, for each countries. Like India has actually told in the global venue that we'll be like we'll be having a net zero by 2070.
Mm-hmm.
Okay, like all our emissions, everything, we'll have a net zero scenario by 2070. I don't know
Mm-hmm.
about Canada, but yeah, so it again depends upon like how the countries can actually, promise all
Yeah.
these things.
Yeah. But
So
do you
yeah,
assume that a country that would achieve net zero would have um lower long-term temperatures than a country that doesn't? Since
exactly.
I understood
Yes.
that climate change is a global phenomenon and the entire world's weather patterns will be affected
Yeah,
differently.
yeah. So the impacts is, the impact is basically globally it will come, but we also do have regional climate models, right? You basically downscale your, you know, from the global models, you actually downscale it to your region of interest. So there is a huge lot of mathematics and statistics involved with these numbers, basically. I'm not saying that like every country will hit,
Yeah.
usually, but again, it depends upon how do you aim it. That's the entire process, entire conversation which actually happens. So have you heard about this COP 30 conference of parties and all which happens? So basically the major debate over there is like, in industrial times, especially the Europe has emitted a lot, right? Like
Mm-hmm.
it was heavily fossil fuel dependent. Now the Europe is actually shifting towards renewables, basically.
Mm-hmm.
Now the burden is actually on the developing countries, right? Like we are actually facing the impacts of climate change, basically, because like as a developing country, it's very difficult to adapt. There are like a lot of economic and social reasons to adapt, right? Now
Yeah.
there is a demand for the loss. We call it as loss and damage. So we are asking funds from global stage, you know, to basically make up the damages that it's obvious that a developing country face more damage than a developed country, right? Because the
Yeah.
adaptation option is more in a developed country, right?
Yeah.
So you need to take all these factors when you
Mm.
actually relate these things.
Yeah.
Yeah,
Yeah.
I hope I have answered your question. So
Okay.
please
So
do
yeah, I
reach
guess
out
it's a
if you have
conversation
any.
for
Yeah,
a
yeah.
different presentation. Yeah.
Yeah, exactly. So yeah,
Okay.
I really don't want to put that because
Yeah.
it's actually very dry. So
Okay.
please do reach out. I'm really happy to help you with any sort of technicalities that you have
Okay.
on like global climate models or
Yeah.
something. Yeah,
Yeah. Thank you.
sure. Yeah. Any
Any
other
other
questions?
questions from our audience?
Yes, I had a question.
Go ahead.
Sure.
Thank you so much for such an informative and eye-opening presentation. So I am a student of economics and I'm also working as an intern with the insurance company here. So my question was that water damage claims are, as I learned, that it is one of the highest among the claims, and this is largely driven by climate change as well. So what do you think that the insurance company's role could be in increasing the adaptive capacity of its insurers and the insured infrastructure, because insurers are usually very myopic and may not want to build like resilient infrastructures. So what could be the role of insurance companies here?
Great question. Yeah. So basically, I mean, I'm not well versed in the insurance sector, but basically what I'll tell you, I'll answer you is like insurance is really important. For example, I'll tell you an example from India. Like we have this crop insurance. Okay. So basically, you can insure your crops so that when an extreme rainfall or an erratic rainfall pattern damages your crops, you get a minimum value for your crops. That's a kind of insurance that basically we adapt. And I don't know how much insurance companies are actually interested in but we should have a policy that again works on a policy level. Like we should have a at a government level, we should have all these things insured against uh, these uh, these erratic climate events. For example, there are insurance companies like who does this thing. You are you familiar about what is that company? Renew Risk and all. Like I forgot the company name. Like they are like reassurance companies, okay, who actually works towards this. What they will do is like they basically perform a they call it as NatCat model, okay, natural catastrophic model. So they just perform this catastrophic models, and they will analyze like how much, how much your home is susceptible or vulnerable towards a particular disaster or a climate hazard. Then they will, kind of insure your property based on that. I think that's how it works. But that culture or that mandate should actually comes from a policy perspective. Yes.
Thank you.
Yeah.
Well, I guess if anyone has any other question, you guys can reach out directly to Hamid because we are running out of time, and we will conclude the colloquia today. And thank you, Hamid, for such an incredible
Thanks a
speech.
lot.
Thank you to the audience for the thought-provoking questions, and we hope to see you all again for the next colloquia.
Yeah.
Thank you.
Thanks a lot.